Hey guys, how's it going? It's Mr. Shirley. We're going to quickly go through a video of sections 5.5 and 5.6 so that you guys can be on track whenever you get back to class on Tuesday. I'm going to go very quickly, so make sure you're making use of the functions the video has available, like maybe slowing it down or speeding it up. Maybe you want to do it at the same time you're looking at the homework or maybe reading the textbook as a supplemental material. It's always nice to be able to pause whenever you want, try the problem on your own, work ahead, whatever you want to do. You guys can see here, like we started, I think the important things today that we're going to talk about, really the things we're going to use a lot are exponent rules. So in here, I'm going to try and use different colors to differentiate, but you guys know I'm colorblind, so who knows, right? But here you guys might remember, if your bases are the same, then you can add the exponents of those bases together because it's like having that many in a row, right? All the way over 11 times, something like that. So that's a big one. Exponent rules we're going to use a ton as we multiply polynomials. So if that's confusing at all, make sure you revisit chapter 5.1, 5.2, where we did with monomials before we started today. And then same thing, we're going to use like terms or similar terms. They might be called a ton. So make sure you're comfortable categorizing look like these variables. Here, this guy x squared and x squared, I color them in blue because they have the same degree. So remember, for like terms to be similar and be able to be added, they must have not only the same variable, so not only the same variable in this case, like these guys have the same variable, but they must also have the same degree. So they must have the same variable and the same degree in order to be like terms. So just remember that as we moving forward. You guys can see here, I had 3 x squareds here and then 4 over here. I added them together to get 7. Same thing for these guys. I had 6 red x's, another 7 over here, added them together to get 13. So same kind of business. Remember your like terms as we move forward, and your exponent rules is probably what we're going to use the most today. Okay, so we're going to start out with an example, and then we're going to kind of get into the rules behind what's going on. So before we even start, let's just break this guy down like a number, like we would any number. You guys see here we have one number over here, 5b, whatever that is. We don't know, maybe some variable, right? And then on the inside we have 3b plus 1. So we can think of this guy. These are two different terms, right? 3b and 1. So we can think of 3b here as one number and then plus 1 like another. So if we were thinking of these, like, let me just plug something in. Let me just think about over here. There's my thought cloud. B was 1 for right now. So we'd have a 5 on the outside and a 3 plus 1 on the inside. Guys, if we wanted to reduce this, we could use the distributive property. We could multiply, maybe let me get a different color. We could multiply 5 in by 3 and then 5 in by 1. Add those guys up. We'd have 5 times 3. Oh, and let me make 5 green. That'd be cool. We can multiply this 5 in 5 times 3 and then plus 5 times 1. So in white, up here I'm going to start. Let's do the inside. Maybe one way we could do it is 3 plus 1 is 4. So we'd have 5 times 4. Ooh, let me keep the colors the same. So we'd have our 5, and then on the inside we'd have 3 plus 1, which is 4. And together that makes 20. 5 times 4 is 20. And then here on the bottom we see something very similar. 5 times 3, that's 15. And then of course plus 5 is 20. So this is not a proof by any means. We've already seen kind of how the distributive property works before. But we're going to take this concept where I had these colors, had my 5, and then I had the 3 plus 1 on the inside. And we're going to use those concepts and apply them right here. So same thing. Let's go back to this guy. And let's just color them. Let's just color them like we would down here. So I'm going to color this number green, 5b, whatever 5b is. Whatever 5b is, we're going to color it green. I'll leave my parentheses maybe white. And then the inside we have two numbers. I'm going to color blue, 3b and 1. The distributive property still applies, and since these guys are all monomials, there's a monomial, there's a monomial, there's a monomial, we know how to multiply those guys. So I'm going to do the same thing. I'm going to distribute this green 5b in, so 5b times, and then here we're left with 3b, right? And we could say, furthermore, we could say this is equal. All right, maybe I'll draw my little arc. There's my first one, 5b times 3b. And then plus, we have a little plus in the middle. And then we have 5b times 1, which of course we know to be 5b, but I'll go ahead and write it. 5b times 1 right here. And then we can actually execute some monomial multiplication, right? We can use our exponent rules. Here's a b, oops, excuse me. Here's a b, here's a b, right? So b times b, that's 2b's, that's b squared, right? So maybe here, and I'll do it in white probably. We'll have a 3 times 5 is 15, and then b times b is b squared. Very cool, plus. And then here, 5b times 1 is, of course, just 5b. Now, these guys are not like terms, because we have differing degree. So this b is of degree 2, this b is degree 1. So that's as simple as it gets. This is the result for this multiplication. Not too bad. So pretty cool example. Not too bad, not too hard to see. All we're going to do is all we take away from this is that we can use the distributive property on polynomials. So we can use the distributive property on polynomials. I've seen a few of you on your exams and such do this in the past, so hopefully this instance is not this bad. This is really the takeaway for this part of the chapter. There's only one more thing we really need to know, and we're going to talk about it on the next slide. Guys, remember, I'm going to go fast, so pause, slow the video down, whatever you need to do to stay on track. So right here, we see something a little bit more interesting. If I was going to think of this like numbers, I have some pieces here, some y's, and then the other side I have some 2's. Pretty cool. But if I was going to do the distributive property here, it'd be hard because I have two numbers. I have two numbers on the inside, 7y and 2, and then I also have two numbers on the other side, y and 2. So what we do to get around this is we kind of do a double distributive property. So first what we do is we'll treat this whole thing here in the parentheses like one number. We'll pretend like 7y plus 2 is one number. We'll distribute 7y plus 2 to both of these guys, and then we'll see what happens. You guys will see we can distribute again. So this method, it's called double distribute, and in a second we'll see it in a kind of different light with a different name. Maybe I'll do it in a color. This is the double distribute. There's a few ways to do this. I can't spell. The double distribute is not too bad. So here, first thing I'm going to do, I'm going to color them like we did last time. I'm going to color my whole outside number green, just like I did before. And then my inside number, I'm going to color those blue. So I'm thinking of this green piece all like one number and these blue piece as two different numbers. Maybe we'll color them to represent that. So I have a y, and then over here I have a 2. So if I take my green number on the outside, I'm going to multiply it in by both terms. So here, I'm going to start by, like I said, treating this first number like one whole number. This whole green number, I'm going to multiply it in. So to get green, we're going to multiply in 7y plus 2 times y first. Get us a new equal sign, and then down here we'll say this is the same as 7y plus 2. There's my first number, and then times my second number, y. And then here's this addition sign. This is the same addition sign right here. And then I'm distributing out my other y on this side. I'm sorry, excuse me, to my other number, I meant to say 2y plus 2 times, and then here's my red 2. Not bad, not bad. So you guys can see what we've ended up with is two distributive properties. We have one over here and one over here. So the double distribute is literally telling us, hey, we're going to distribute once, and really it should be called triple distribute, it looks like. Because here I'm going to distribute once to get this guy, and then I'm going to distribute 2 more times, like we did on the previous slide. Multiplying the y in to get something very similar. So anyways, without further ado, we can say this is by distribution. Now I'm distributing in this blue number to both. 7y times y. And then I'll have a plus. And then we have a 2 times y. Plus. And then we'll do the other distributive property with my red. Let's see. We'll have 7y. And then you can say times 2. Plus. And then there's a green 2. And then there's our red 2. Very cool. As you guys can see, we have a bunch of simplifying to do, so we'll just go ahead and do it. 7y times y, of course, that's 7y squared, plus, and then here we have a 2 times y, that's just 2y. And here we have a 7y times 2, so 2 times 7 is 14, but there's nothing to do to the y in this case. And then here we have a 2 times 2, which is 4. Not too bad. But we're not quite done. As you guys can see in the middle, we ended up with some terms who have the same variable part and the same degree. So these guys right here are like terms. And of course, we won't color them for right now since they're so close to each other. But we know that 2y plus 14 more y's, well, that's a total of 16 y's, plus 4. And this would be the result of your multiplication because there's no more like terms, no more simplification to be done. So that's the first way. So the first way, the double distribute, we saw that you could do it that way. I'm going to show you guys another way. You may have also seen FOIL. I'm not going to show that today. But FOIL is cool. It stands for first, outside, inside, last. You can do that too. I'm going to show another way that generalizes a little bit better. So let me go ahead and erase this. Ooh, iPad does not like that. Oh. Oh no. Okay. Not sure what's going on here with those floating particles. I don't know. Interesting. Usually they go away after I undo. Oh, I just have to swipe, apparently. Okay. So, guys, I'm going to show you the second way for today. The other way, you may have heard, is called box method. Tons of ways to multiply. You guys let me know if you want to do a FOIL video or in class or whatever. We might do it. It's pretty much the same as double distribute. Well, I mean, these are all pretty much the same. They do the same thing for us. But FOIL seems to confuse the students, so I avoid it. Not too bad, though. Let's try box method. If you guys like FOIL, though, please use it. Use whatever you want. I'm going to use box method real quick. I'm going to show you guys this. So the way box method works, the way box method works is I'm going to think of these guys like a collection of 2 numbers each. And then, whenever I group them together, and I'm multiplying these numbers in parentheses together, those algebraic terms, I'm thinking of one kind of like length, and I'm thinking of the other kind of like width. So if you look at it, it kind of looks like there's a length here times some width, right? So it kind of looks like area. So what you might do, and this is what box method kind of plays on, is it's like calculating area. Where one side is, and maybe we will color it. So 7y, one side is 7y plus 2, that's this term, first term. And then the other side is y plus 2. And then it says, well, since we're adding, this is like splitting up this piece here and here. Oh, maybe I should move this guy over a little bit. And then the multiplication, you just solve for the area of each of these squares. So the area of this first square here, we can see that the area is length times width. We can see that the length is given by 7y, and the height, or width in this case, either way, is given by y. So we might say this height here is 7y times y, which we saw earlier. Same thing exactly here. I'm going to do 2 times y, not that bad. And then same thing here, 7y times 2. And then for the final case, we have 2 times 2. If you use box method, you will always end up, well, not always. Most of the time, you will end up with some like terms. Here we can see that we have a y and a y here. Anytime you really do multiplication in general, you should always check for like terms. So here we check for our like terms. We see that we have y and y. So I'm going to take out this term right here. We know to be 7y times y is, of course, 7y squared. So I'm just kind of writing it over here. This is kind of like, I'm just going to write it like my output. And then here, 2y, that's just 2y. And then 2y times 2, that's 14y. And then here 2 times 2 would be 4. And then we can simplify our like terms in the middle again, just like last time. Oops. 7y squared plus, and then 2y plus 14y would be 16y plus 4. Okay, nothing too crazy. We're going to move on to the challenge problem that you guys can try on your own and then check against my answer. And then you guys be ready for the homework for this section. So for the challenge problem, it's a little bit kind of the same. This is why I really like the box method. It's going to show us how the box method generalizes to any, not just binomials that we saw previously. So in this previous case, we saw a binomial times a binomial, 2 pieces times 2 pieces. And then here we're doing a binomial times a trinomial. So if you were going to do the double distribute, in this case it would really be triple, because you'd have to do more cases, right? So same thing for us. We're going to use the box method, though, because it'll simplify it a lot. So on one side, I'll have x minus 6. Ooh, let me do a color. On one side, we have x minus 6. That's this side. And then the long ways, we're going to need, so we have 3 terms. We have 3 terms, so for the box method setup, I'm going to use 3 sections, 1 for each term. Not a great box. That's okay, though. So here I have a split, so that I can have this term on one side and this term on the other side. I'm going to come down, put these guys over here. X squared. Now remember, my next term here, my term here is negative 2x. Negative 2x. So in this case, I'm not going to put 2x. I'm going to put negative 2x, keeping my signs together. And then my 4 goes down here. So same thing, let's continue as we were going. Here we have an x times x squared, which would be x cubed, right? Minus 6 times x squared, that's minus 6x squared. It's really, we're not hearing anybody in the classroom or seeing any faces. Negative 2x times x, that's negative 2x squared. Negative 6 times negative 2x, that's this next box. Well, negative 6 times negative 2, that's a positive 12x. If we forget, we can just try our triangle out over here, negative, negative, positive. It's kind of hard to cover this. But here we had 2 negatives, so if I covered negative and then covered negative, I'd be left with positive. That's kind of hard to see, but hopefully that came across. That's a cool trick to remember if you want to use it. And then here, of course, 4 times x is just 4x. Oops, made a little. Just 4x. And then negative 6 times 4 is, of course, negative 24. So now whenever I write all my terms out on this side, let me give myself a little more space. Pretty nifty, right? You guys should get this app. Oh, there we go. Over here, when I'm translating my steps, I'm going to start. I like to start personally. You don't have to, but I like to start with my highest degree terms first, and then go kind of like this. And if you've done your multiplication right, usually you end up with your like terms next to each other. Not always, but usually the next to each other makes it a little bit easier for the next step. So here I'm going to write equals to, that's for this. This guy's equal to x cubed, my first term, minus 6x squared, just translating, minus 2x squared, plus 12x, just adding all these guys up, keeping their signs the same, plus 4x minus 24. Wow, you went right up to the edge anyways. Here I see I got some like terms hanging out. Let's see. Looks like I have x squareds here and x squareds here. And let me just highlight the variable. I have an x squared here and an x squared here. And then here I have an x and an x. And those look like the only like terms. So simplifying those, keep x cubed the same. Negative 6 and negative 2, of course, is negative 8x squared. Plus, and then here we have a 16x, then minus 24. Guys, since there's no more, terms, or I should say variables with the same degree. There's no more variables with the same degree. There's no more like terms to be done, and this guy's variable is actually hiding. It's an x to the 0, right? These guys must be, he must be done. He must be finished. This will be the result of our multiplication. Guys, that's all I have for section 5.5. You are more than ready to attempt the homework. If you have questions, please email me. I'll be ready to respond. Watch the next video, which we'll try and keep really short for 5.6. Then that on class we could be done.